Okay, so it's broadcasted.
Yeah, it says live, so that's good.
So does it mean that later on it's just going to record on them? We can just put the link because the last thing we want is to record this to be done, and I can't find a way of putting it up. So
Yeah, I think that's how it goes. I've never done it because the other two didn't,
okay,
but I think that is how it goes.
alrighty, well then we're on. Okay, I mean I watched a few. I watched the extra videos they added, and it's not. This lesson is not super complicated, so I kind of feel like we will be done in just a few moments.
Okay. I reviewed uh the lesson, did like the practice stuff,
Uh-huh.
but I didn't get to watching the videos yet.
Yeah. It should be fine. I mean, it's not that complicated unless I just have it wrong. Yeah, that's just a total of 12 questions.
Okay.
All right, so question 3. Okay, so if you have a sample size of 5, then the population, then the distribution of means will be very similar to the parent population because, the sample size is wrong per the rule of large number, no, per one of the rules.
Mhm.
So it should, if the parent population is right skewed, then it would also be right skewed. However, if the sample size is 100, then it would be normal because you have a larger sample size. Is all of that making sense?
Yeah.
Okay. Okay, so the shape of the histogram, well, it should be right skewed as well, if I remember correctly, because it would not be a normal, it wouldn't be normal shaped or bell shaped. But if the population size is large, like 100, then it would be bell shaped. The shape would be normal.
Okay. So we have skewed right, and then we're on number 5.
We're on number 7.
Oh, we're on number. Okay, so 3 is skewed right. Right.
Uh-huh.
4 is skewed right.
No, 4 is normal.
Normal. Oh yeah, you said 100 is normal. Okay,
Yes.
It's been a long day. Okay, now I'm gonna try to catch up with you.
Okay, and then 5 is skewed right as well because the population size is still small.
Okay.
And 6 is normal as well because there's a large population. Then we're on 7.
Okay. Okay, I'm caught up now.
Okay, so what would the distribution of means be normal?
This was on the preparation assignment, wasn't it?
Yeah, let's see. So data is drawn from a population that is normally distributed and the sample size is small. So yes. Data is drawn from a population that is normally distributed and the sample size is large. That is correct as well. Data is drawn from a population that is right skewed and the sample size is small. That would not be normal. And data is drawn from a population that is right skewed and the sample size is large. That will give you a normal distribution of means. So all of them except the third
Third
one.
one. You're
Yeah.
okay.
If I understood the lesson correctly. Okay.
The central limit theorem.
I'm leaning towards the third one, but I could completely be wrong.
Sample size is large, the sample mean close to the population mean. I remember something about that in the text. It was like if the mean is, well, this doesn't make any sense to it, but the mean's high, then the standard deviation would be low, I think. That doesn't make any sense.
Let me see. Let me read it again, see if I can confirm. So the central limit theorem says as the sample size n increases and becomes large, the distribution of sample means becomes approximately normal. So in other words, the central limit theorem is like the more and more people or the more and more the observations you make, the mean that you have becomes normal, meaning it becomes bell shaped. Your histogram will look bell shaped.
Okay.
So let's see if the parent population is normally distributed and the sample mean would follow a normal distribution. Not really. If the sample size is large, then the sample mean will be close to the population mean. Yes.
Okay, so it is 3.
That's the closest I can think.
Okay.
Okay, so oh, there's someone trying to join.
Oh, really?
Yeah. I just asked whether that was Iris. I would say. So let's see. What is the mean of the distribution of sample mean? So the mean is always the same as the mean as you have. So the mean is going to be 10. What is the standard deviation of the distribution of means? So the standard deviation from the formula you have
6.
well, I'm asking her whether she got the invitation.
That's it's fine. Leave it alone.
The cakes
I know.
are yeah, Mom done.
No.
Mom, where's the light?
I don't need you to. Thank you, though.
When are you gonna do it?
Okay.
Are you done with your talk thing?
I'm on here right now, Leah. Sorry, that's my little sister.
No, you good. All right. So for the standard deviation, it's just you're going to have. Let me turn my stuff on here. Okay, so you're going to have the standard deviation in here, which is 6 divided by the square root.
Oh, I see that formula. I'm on that part of the chapter.
Yeah, divided by the square root of your sample size, which is 36 right now. Oh, that's 1. So I guess standard deviation is 1.
Sweet.
Let's see if my math is correct. Square root of 36 is 6. 6 divided by 6 is 1. So, All right. 11. Regardless of the distribution of population, so she says she got the invitation, but her laptop is super slow.
Oh, okay.
So if the sample size is large, meaning that n is greater than 30, what would be the shape or distribution of the distribution of this? I mean, it would be normal.
100 is normal.
What theorem would justify a response for the last question?
Central limit theorem?
Yeah, it should be central. I mean, law of large numbers, it's, what was it even? That has to do with mean. The law of large numbers, I think it says that the larger the group or the larger the observation, the closer your mean, your sample mean would get to the population mean. Something like that. Well, let me give it a shot and see what happens.
Okay. You really got this class down.
Not really, no. Some of them are just simple.
Well,
and some of them are very complicated.
I'm overthinking it.
Yeah, it's just go with the lesson and what it says, and you should be fine. We had a few wrongs. 2 wrongs. Yeah. So it was the let's see. No, that doesn't make any sense. So we made 2 mistakes. So question 5. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed? 5 is normal. Why did I click skewed? Don't you have 5 as normal?
Me? No, yeah. I have skewed.
It should be normal. I'm not sure why I said skewed. It's normal.
That's okay.
Okay, so change 5 to normal, and let's see. Question 8. Which of the following gives the best explanation for central limit theory? So the one we chose was wrong. So the last one, if the sample size is large, the shape of the distribution of sample mean would be approximately normal.
Let me look back on the...
I think it's the last one.
Yeah, that sounds right. Like it kind of sounds...
Yeah, so choose the last one and check it and see if...
Okay, I'll go and turn it in. Oh my goodness, can you hear my mom?
Yeah.
I'm so sorry.
my mom is just as loud, so you're good.
I'm the only member of the church in my family, so it's very funny. We got 100%.
Awesome. I will give it a
Awesome.
shot again. So, cool. See, said it was gonna be pretty short.
Awesome.
So, yeah. Let me see here. So I guess we are done.
Mhm.
And well, we will see you on Wednesday at 6.
Mhm. Are
Gonna,
you gonna do the thingy again?
I can do it. It's not a difficult thing to do at all.
Okay, and then you'll have to show me how to do it next Wednesday.
Sure.
Remind me.
Sure. All right.
Okay.
I guess we just stop broadcasting, and
Okay.
I'll post the link. So,
Okay.
alrighty. Well, we will see you on Wednesday.
Okay.
Okay. See ya.
Mhm.